One of the most important parts of the archaeological and fossil records is understanding how old things are. When it comes to understanding the real ages, the dates of geological layers, of paleontological sites, and of archaeological sites, we use very specialized techniques. And geoarchaeologists and geologists are real specialists in this kind of dating. Andy Herries, who's an Australian research fellow, who's the head of the Archaeomagnetism laboratory at La Trobe University in Victoria, Australia, is an expert in dating the sites of South Africa, sites in caves, like Drimmelen, where I found him. And those cave sites are among the hardest to date. When I talked to him at Drimmelen, we talked about some different dating methods. We talked about Potassium-Argon dating and its use in East Africa. We also talked about uranium series dating and other methods that are used in the South African cave sites. I tried to get him to give us an appreciation of the complexity of dating sites in the archaeological record and the way that our understanding of the dates of African sites has really improved within the last 10 years.
How do we know how old anything is that we find?
Okay, in South Africa, working out how old most of our fossil sites are has been a real problem. So in East Africa, where a lot of hominid fossils come from, they have a lot of volcanic material that you can date using a method known as Potassium-Argon or Argon-Argon, and that very precisely dates volcanic layers that sit above and below the fossils. In South Africa, we don't have any recent volcanics, so traditionally what's happened is that we actually use the fossils themselves. And we basically say, well, we have these fossils here in South Africa, we have similar looking fossils in East Africa we know the age of, and we can compare the two.
So we're talking about fossils, you mean like all of the kinds of fossils in the site, you know, animals?
Yeah, so mostly traditionally it would be pigs in particular are extremely good, carnivores are quite often quite good, various types of antelope are particularly good, sometimes even micro mammals, so things like rats, voles and those sorts of things. Fundamentally, the real problem with that, obviously, is that the sites in East Africa are, you know, thousands and thousands of kilometers away.
Sure.
And we don't really know that the same species were wandering around the landscape in South Africa as in East Africa at the same time, or really that they are exactly the same species. Often they have some similarities, but they're not always the same thing.
Okay. So your work involves the geochemistry, the geology of it. How do you proceed to try to do better?
Yeah, so you know, about 15 years ago I started doing my PhD. So I do a method known as paleomagnetism. So the Earth has a magnetic field, and basically when any sediment is washed into a pool of water, as all of the little grains fall out of suspension in the water, the little magnetic minerals inside them align themselves all together with the Earth's magnetic field at that time. As they then settle on the floor, it becomes compacted, and that fossil direction becomes actually set into that sediment. And what not lots of people know is that the Earth's magnetic field actually completely reverses itself every now and then.
Right.
So 780,000 years ago, the Earth's magnetic field was going the other way.
Yeah.
So your compass would point the other way. What is south at the moment would essentially be north. So we can actually then go to the sequences in the caves and we can measure which direction the sediment is going. Is it towards north or towards south? We basically work out where those points are, and we know the age of those reversals because as the sea floor is being formed, we get this perfect record of it because it's set in as it basically cools on the seafloor. So we know for the last 5 million years quite well what the record is like, or at least we know the major changes. The unique thing about South African sites, the caves, is that you can get very high resolution sequences. So you can actually get these really, really small, short events that only last a few thousand years. So we are really working on the sort of finer grained siltstones and also on, yes, the Speleothems or the flowstones. And the flowstones are perfect recorders. Once the grains are set in, they're set in and fossilized and they don't move. And they also record a longer time period because they take longer to form than the sediments, which actually sort of wash in a lot quicker. And the sediments can always have problems of you know, mud cracking, so you get slight changes but not huge amounts. The big trick is that we know that there's a reversal in a site, for example. We need to know which one there is. There could be more than one possibility.
Right.
So we can use the fauna sometimes. That gets us in a particular place. Sometimes we're lucky and that tells us everything. But what we generally tend to do now is that I do the paleomagnetic work, and then we will date the flow stones. So we do that using a method known as uranium lead.
Yeah.
So there is another method known as uranium thorium. It's part of the same decay chain of minerals. And that only unfortunately goes back 500,000 years. Using uranium lead is a much more recent method, and we couldn't do it until recently on younger sites because essentially not a long enough time had elapsed for one mineral to decay to the other,
Sure.
one isotope to the other. So, but now we have a situation where we can date the flow stones in the caves. So that basically gives us a marker, and we know that that is that age. Of course, the fossils aren't in the flow stones.
Right.
That's where combining methods is the real trick. So you date that layer there, and we go, okay, so this is sort of, say, 1.89 million years or something like that. And then you can basically then say, oh, well, I know that there's some reversals around there, and we use the paleomagnetism to track down to them. And we then get that layer and we say, right, that's that age, that's that age. And then we can date the fossil layers. And again, if you've got a complex geomorphic history, which again brings us back to geology, and it has to ultimately also come back to stratigraphy.
Yeah.
Caves, how they form, the stratigraphy that's there.
Yeah.
And I think traditionally, most of the sites that were studied, they studied, the later phase, which is where all the collapse was happening, all the fossils are there. But what we really need to do is understand the cave's life histories from beginning to end. How did the cave form? What was its speleogenesis? How did all the passages form? How was it then cut open to the surface? Is there one entrance, two entrances? And only then can we sort of put it all back together, because I've been caving since I was 17 years old, and I've been in a lot of caves in a lot of places, and they're complex things. And, not many geologists or paleomagnetists really work in caves. They have their own unique set of rules. You can get weird situations where traditionally you think of, the sediments at the top are the youngest and the ones at the bottom are the oldest. But there's a fossil site in Australia called the Wellington Caves. And in actual fact there, the older stuff that's like 2.6 million years old is above the stuff that's about 1 million years old. So it's completely inverted. And unless you understand those complexities, you can end up getting yourself in a real muddle.
Now, people probably imagine, folks that are specialists that are working on dating and that sort of thing, sort of parachuting into a site and taking samples, and then they're gone. They go back to the lab. You're out here working, excavating. I
am, and that's the difference. Ultimately, I think, because I'm an archaeologist. I trained as an archaeologist. I did archaeological science. I then did geoarchaeology, and it wasn't until later I moved into geophysics and geomagnetism. I do this because I'm interested in hominids. Ultimately. I'm interested in the big questions of how, you can look at how all of these species relate by looking at their difference in anatomy. But you can also do that by putting them into a temporal line and saying this one is this age, that one's that age, this could have evolved to that, that couldn't have evolved to that. And ultimately that's what I'm interested in to a certain degree. The paleomag and the geology, I love caves as well. That's my other obsession, so I've got both. But I do those methods to really understand that question. And there are more people now who have come that route from archaeology into those disciplines. But still, a lot of people that work on site geology and dating are geologists or geophysicists, and they're interested in other questions, and they do this work and give you dates, but they're not as integrated in the same way. They don't understand the archaeological questions as much, maybe, and so I think that's one of the real benefits. And I think again that's sort of what I'm trying to do where I teach in Australia, is to bring more people into the discipline, doing that geological thing, geoarchaeology, etc.
So if a student is interested in getting into this field, what would you suggest they do?
My personal view, for me, I had a very wide-ranging background. I always did science. Archaeology is more scientific these days. And I think if you want to be a field archaeologist, you want to go out there and dig, one of the big challenges is that you have to understand a bit about everything.
Yeah.
You have to realise that you don't know everything about everything, but you have to sort of at least be able to understand a little bit about what all of the various people that come in onto your site do. People are doing dating, paleoenvironments, geology. So I think it's very good to have that sort of very broad background.
Sure.
And the other thing, what I will always say to my students is also think about what all of the other people are doing in the world. If there's 600 people doing stone tools, you know, find something that's a bit different, a niche that you can get into.
Yeah, sure.
So, I mean, I'm very lucky. I get invited to go to lots of sites, see lots of things, do lots of dating, and it's travel the world, and it's great fun. So,
well, brilliant. Thank you so much.
Thank you.